afternoon, good day, good morning, wherever you are watching me from. In this video, I would be explaining sampling in educational research, and it is also applicable to other types of research. So we would look at population versus sample. We will look at probability and non-probability sampling methods. We will look at decision making in research design. We will look at bias and validity, and also generalization. So a good sampling is not about size alone. It's about fit between method and research purpose. So a good sampling is not about bias alone. It's about the fit between method and research purpose. So what is a population and what is a sample? A population is the entire group of interest done in a study. So then the sample is a subset selected for the study. So because the researcher always find it impossible to select everybody in a particular population as participants in a study. For instance, let's say somebody is doing something around nursing mother in Ibadan, or in New York, or in Johannesburg, or in Kenya, in the capital of Kenya. It may be impossible and costly to locate everybody who are nursing mothers, but through sampling, one could draw inference about the entire group. So it is good to say that sampling makes us a very good way, a very easy way to carry out the research without locating the entire population. So a sample should represent the population as closely as possible. If we have to sample beggars, in African community we have beggars, and we now found a beggar that has 4 houses, 2 cars. That is not the representation of a beggar, because of the poverty that is a major indicator of their lives. Now, let's now talk about why sampling matters in educational research, or not even only educational research, in research, because it influences the validity and trustworthiness. Poor sampling creates misleading conclusion. For example, if I am using a method to improve student achievements, and that particular method is a method that is I'm sampling students that are already very excellent in that area, and I now claim that the method is working. My wrong sampling is actually making the method to appear to be working, but the real thing is that the method is not what is working. So you can see that sampling must be very important. Now, imagine that I am also sampling 2 schools using a particular method. And the second school where I am implementing the method is a school that is excellent, while the other school that I selected as my control is a very, very poor school in terms of academic excellence. And I now said the other school, the method worked. I'm supposed to pair 2 excellent schools and see whether the method will make a difference, not sampling that way. So sampling affects fairness and representation, you know. So the takeaway from this slide is that weak sampling weakens the entire research study. So the next thing I would love us to look at is sampling and generalization. Generalization simply means that applying the findings to a wider population. This has to do with the external validity of the result of our research. Representative samples improve external validity. So biased sample reduce the confidence in findings, and qualitative studies may prioritize depth over generalization. So that's why most of the qualitative study, we will get into it, hardly use probability sampling because they are not interested in generalization. But in quantitative study, our intention is generalization because the research outlook is reductionism. That means positivism, and our thinking is reductionist in its outlook. So that could actually work. So the thing to think about is that sampling decisions shape how far your finding can travel. If your sampling decision is poor, your sampling decision will determine how far you could take your claim. For instance, if I carried out a study among patients in tertiary healthcare, um, tertiary healthcare uh, facility, in that place we have all the medical fields represented fairly. You will have all the departments. There will be a radiology. Nobody is hardly going outside to take a scan. The radiologist department is there. All the kinds of departments are there. So if I want to now generalize, I will not generalize to say being in an hospital. My generalization will say being in a tertiary healthcare. Similarly, if I do a work in a private school, I will not be able to generalize to say in schools. Because if I say in schools, it means in public and in private. Since I did not sample both of them, I will limit my thoughts to private school. This particular sketch is types of sampling, and we will be looking at them one after the other. So we have 2 methods. We have the probability sampling, when in this place every member has a known non-zero chance of selection. That means everybody has a chance to become part of the sample. But in non-probability, not everybody has a chance. When I was being introduced to this concept as an undergraduate, my teacher illustrated with the television interview. in those days there was no internet, so we only have okay, we had internet, but you know, it wasn't on the mobile phone, so we only have cyber cafe, and there were no internet television. Online TVs were not available. So the only TV that is available is the terrestrial television. And what happens is that this terrestrial television usually interview people. They will just get on the streets and they will give somebody a microphone and say, what do you see to the new fuel price? So that my teacher said that the respondents in that case was just one or two or three. Many people were excluded. So, because the person just gave the microphone to people he never met before and they just spoke. So the chances in non-probability sampling, the chances of exclusion is high. While in probability sampling, the chances of exclusion is low. And I will run through them one after the other. Let's start. We have the simple random sampling, where every individual has equal chance of being selected. We have the systematic sampling, where a particular number of persons is selected. We have the stratified sampling, where the population is divided into strata, random sample from each stratum, and all of that. We have cluster sampling, whereby the population is divided into cluster and randomly a cluster is selected and survey all or some within the cluster. This last one is category sampling. I wouldn't want to dwell into it so much, but it is not a sampling procedure in its true sense. But what happens is that when you switch from one category to the other of sampling, that's when it is talked about. So under non-probability sampling, we have the convenience sampling. That's what those radio stations use. They will just who are easily accessible on the road. The next to that is the purposive sampling. In the purposive sampling, what we have is that individual who are most if who have a particular characteristics that we are looking for as sample. For instance, if I go to a school now and I want to sample students who are left-handed, you know, the population of left-handed students in a class, you may not even find one. So when you have a criteria of sampling, that's purposive. We have the quota sampling, where quotas for subgroups and non-random selection within each quota is there. We have snowball sampling, where we look for people with similar history. For instance, if you are looking for teenage girls who are rejected in their home as a result of and they are as a result of who are out of school because of teenage pregnancy. When I interview one, the other person can give me information about the other one who has experienced it. We have consecutive sampling, which include all eligible participants over a defined period of time. This is usually used when we have a need to talk to a group of people who are experiencing something similar, you know, for the purpose of sampling. So let me go to it one by one very fast. We have the simple random sampling. We will just look at it. It has so many dimensions. So let's assume that we have a large class and we want to divide the class into 3 classes, a large class. We now did a ballot, 1, 2, 3 in many places, maybe in 100 places. We now told the student to pick randomly. So after everyone has picked, we now say, all of you that picked 1, stand up. You are going to class A. All of you that picked 2, stand up. All of you that picked 3, stand up. Simple random sampling give equal chance of selection, you know, and the randomness reduces research bias, but you will require a complete sampling frame. So I will not be able to exhaust uh, the number of ways to do the simple random in this place, but that is just the simple thing about the simple random. Next is the systematic sampling. This is also a probability sampling whereby the participants or the member of the population are numbered. Well, let me just tell you this. It is a sampling approach that is well known in industry. For instance, for quality assurance purposes, let's say there is a cookie manufacturing plant and we have tasters. It is impossible for the tasters to taste all the cookies and check for quality assurance. So what happens is that they will select one cookie, maybe out of every 100 cookie number 100, they will just pick it. And when they pick cookie number 100, the next time they will pick another cookie is cookie 200 to taste, to check for quality. The next is they will pick cookie 400. So in systematic sampling, uh, the a fixed number from a list, maybe in the lab we are looking at the 4th member of every team that are doing team lab work together. So it is that 4th member. We go to the first group, we select the 4th member. The second group, we select the 4th member. So it is always, the probability is also there, you know, and it is efficient for large population. That's why I said about that cookie industry. Um, this is simple, but it depends on the list of a particular quality. Next is the stratified sampling. When the population is big and you want a true representation, you may stratify. Let's say you have 10 educational zones in a local government or in a state, and you want to research all the schools in that state. So you will already make the strata are already existing. So an educational zone is a strata. So within the educational zone, you can now randomly draw out schools and sample the students there. So it allows true representation. It's like saying you want to sample Nigeria and you decided not to go to up north. You must do everything. Say, because of insecurity, in some places in the far northeast, and you decided to call, it's no longer Nigeria if all the strata of Nigeria are not well represented. So we have another one which we call cluster sampling. Cluster sampling is used when we want to select from a geographically dispersed population because of the cost and travel burden. Look at this case when we have uh, the north now, and you want to work on it, and let's say you are in somewhere in Borno State, and within that cluster, there is so much within that place, the population is dispersed, the distance you will cover is much. You can decide to do cluster sampling, whereby you will take, like stratification, a cluster of people and sample the entire cluster or part of it or two or more cluster as a representation of the entire population. I would not want to talk about multi-stage because it is not a sampling method. But when you exceed one type of sampling method, that's where you go into that. The next is the convenience sampling. The convenience sampling is when you select based on easy access, like the journalists. Is having high risk of bias. It is useful in exploratory research. You just want to know, you want to explore. And it is not true representation. You just talk to people who you could see in a particular time. Next is the purposive sampling. You select people who have rich information. It is useful in qualitative study. It focuses on depth other than relevance. There is a criteria for the selection. It is not suitable for experimental study because your generalization will be limited to the characteristics you have deployed. So you went to do a study among gifted children and you want to generalize for all students. Because you have used gifted children, you are already using purposive, and your generalization will be limited among the same category of people. So we have quota sampling. The subgroup are identified and quotas are filled. The selection within group is non-random, ensures subgroup visibility and still vulnerable to selection bias. It balances structure and practicability. All this sampling will be dealt with one by one in another video so that this video will not be too long. So we have snowball sampling, whereby participants recruit additional participants, and it is useful for hard to reach group. For instance, if we are dealing with victims of rape and those people who have experienced um, um, marital crises that are very tough, maybe a friend can say, I can refer you to my friend after being interviewed. So we are taking advantage of social network among out to those rich people. It is the first person that is making us to reach out to the other. We have consecutive sampling. All eligible participants are included over a period of time. More systematic than convenience sampling, and it is useful for longitudinal study. Is depending on particular participants' availability. So consecutive sampling improves coverage over time. So How do you choose a sampling method? You must consider one, your objective of the study, two, availability of a sampling frame, three, budget and time, five, population accessibility, and desired generalization. If your generalization cannot take care of the budget, you change the objective. And if the budget cannot take care of your desired generalization and you don't have time, you change the objective to reduce the size. You know, look at this example, sampling teachers across rural schools and all of that. Now, decision tree for sampling choice. Number one, you must ask yourself, do you need generalization? Is sampling frame available? Is the study quantitative or qualitative? How accessible is the population? Need generalization? Yes. If you need generalization and your answer is yes, the next thing is that you will think of probability sampling. If your need for generalization is no, you may not need probability sampling. If you have sampling frame available, yes, you may need a random method, probability. If there is no sampling frame, you may have a flexible method. So now, probability versus non-probability is probability is equals to random selection. Non-probability is non-random selection. So probability supports statistical inference, while non-probability support deep contextual insights. So if you are doing anything that you want to use statistical inference to draw your conclusion and generalization, it is good to choose from the probability side. But if you are looking for deep contextual insights, the non-probability is very better. So look at this table that I want to share. So probability method reduces bias but cost more. Non-probability methods are cheaper but risk bias. Quantitative study often prioritize generalization. Qualitative study prioritize depth. So look at the criteria. The criteria is that if you have bias, then the probability will be lower. If you have bias, the probability for non-probability higher, and it is best for quantitative study. Now look at if the cost is another factor. When you have a lot of money to spend, it's better you do probability sampling and you don't do this one. Then the best fit is smaller studies. If you want generalization, you need strong probability sampling method, and limited this. So best fit is policy versus exploration. If you have flexibility, that's what you're thinking about, you may not do plenty of probability and higher you take more of non-probability sampling and qualitative study. So no sampling method is perfect. It depends on what you want to do and how you want to do it. Look at this National Literacy Survey. The goal of the survey is to estimate literacy across regions. The population is geographically dispersed, and multi-stage sampling is practical. That means you have to go in several stages, Would this, so think about this, sampling teachers in many areas like that are matching the scale. Let's talk about student disengagement. To understand why students disengage, need rich personal experiences. So as a result of this, you may need non-probability sampling because you have to interview people who disengage. So depth is more important than representativeness. So if you find 5 people who disengage, it is okay in this kind of study. So common sampling mistakes that you must not make. You have not to confuse large sample with representative sample. You know, you have make sure you don't ignore bias. Don't use convenience sampling without justification. And your selection procedure must be well documented. So the next thing is that avoid excluding vulnerable groups unfairly. They are still students, even if they are in the rural area, and you are working on students in that geographical location. Next thing, protect the confidentiality in small group population. Ensure voluntary participation. Explain inclusion and exclusion criteria clearly. For methodological justification, the researcher must justify the sampling choices and explain the limitation honestly and align the method with research objective and also acknowledge effects on generalization. As I conclude, sampling quality depends on alignment with purpose. So probability methods support broad inference, non-probability methods support deep exploration. So researcher must balance rigor and practicability. So the key takeaway is that the best sampling method is the one that best fits the research purpose. Thank you very much.